Right, so this one, the next one we're going to do is Nand Gate. So what did the symbol for this look like?
It has two inputs
Yeah.
and uh it's the same as and but it has a dot now.
Yeah, so we're going to make the same symbol with a dot in front of it, and that's because it's derived from the AND gate and the NOT gate. So it's like a merged version of the NOT and AND gate. And the expression for this, X here, expression for this is A,
Dot
sorry,
B and dash
yeah, dot B, and there's a big bar over it.
the bar on top.
Yeah. Now let's make the truth table. And you have two inputs here, A, B, X, the output. I'll make one more just so it's easier to find out the X value. So I'm going to make sort of 4 columns. What are the inputs going to be?
For A they're going to be 0, 0, 1, 1.
0 and 1, 1.
And for B is 0, 1, 0, 1.
Yeah. And so when we
And
multiply the first two,
it's going to be 0
yeah.
and then 0
And
and then 0 and then 1.
and when we come to X, we're just going to invert this column right here. So
Yeah.
it's going to be 1, 1, 1, 0.
Yes.
Right. Next, we have the NOR gate.
Um, it has two outputs.
Two inputs.
Two inputs and one output.
Yeah.
And
And
it's plus.
yes, and it's the diagram is the same as the OR gate, but with a circle in front of it, and then X the output. Um, we're just gonna write the expression as A plus B, same as before, but with plus instead and a bar on top. And then we have the truth table. Same inputs, A, B. I'm gonna make one for A plus B as well, and then X. So we have 0, 0, 0, 1, 1, 0, 1, 1. After adding these,
Um, 0, 1, 1, 1.
yeah. And then for X, we're just gonna invert this column, which will become
1, 0, 0, 0.
exactly. Okay. These were the basic ones that we had learned. Then there was one more, which was the Xor Gate.
Yeah, the Zor Gate.
So do you
Um,
remember the expression for that? I could write it again since it's a little lengthier.
it's confusing though.
Yeah,
I
yeah, let
do have
me
an
write it.
expression.
Okay.
It's A dot B, like A dot bar B and plus plus bar A dot B.
Yep. A bar dot B. This is what X is equals to. And the symbol for this was we could make like basically the same two inputs with one bar here and another one, and then this and this. If I'm not wrong, let me just double check that real quick. Yeah, okay. And that was the output X. Let's make the truth table for this. So, I mean, I could make all of this. Actually, I'm gonna make one like, explaining this whole part, but the actual symbol for the Xor gate is represented with a plus with a circle around it and then B. This is like what Xor means in the Boolean expression. So basically this expression A Xor B is also equal to A dot B bar plus A bar dot B. It's the same thing. They just made a shorter version of for it since we have to use it again and again. Now, truth table. A, B. I'm going to make one truth table for this, and then you'll see there's a shortcut to making the truth table as well. I'll make that afterwards. Now, let me make one column for A dot B bar, another column for A bar dot B, and then one final column for the output X. And 0, 0, 0, 1, 1, 0. Right, so here in this A dot B bar, we're basically multiplying zero, like A's column into the opposite of whatever B has. So 0, the first row is 0 into 1, right?
Yeah, it's gonna be 0.
And then 0 into 0, 0. And then 1 into 1.
Is 1.
Yeah.
0.
And then 1 into 0, 0. And then similarly with this, 1 into 0 is 0. 1 into 1 is 1. 1 into 0 is 0. Sorry, 0 into 0 is 0. And 0 into 1 is 0. And now X is basically adding these two columns, this plus this. So it's going to be 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And then 0 plus 0 is 0. Now, this was the expanded version of the truth table, right? Like you have two extra columns inside, and you have to find B bar and A bar as well in the middle. Now, if we want to make it for this, just like directly, there's a shortcut to this. So basically what the Xor Gate does, or the Zoro Gate does for us, is that whatever the input is, if the inputs, I'm making the inputs again, if the inputs are the same, like if A is equals to B, then the output X is equals to 0. But if A is not equal to B, then the output X is going to be equal to 1. So I'm just going to write if, then here, and if, then here. So now you notice in this thing that we made, these were the inputs that we had, and this is the final output that we had, right? So notice how every single time we had A equal to B, where 0 is 0, A is 0 and B is also 0, the output we're getting is 0. Let me just change color here. So here, 0 and 0 are giving you 0. Here, 1 and 1 is giving you 0. And that's because A and B are equal to one another. But notice in the other two rows where A is 0 and B is 1, we're getting 1. And when A is 1 and B is 0, we're getting 1. Meaning when they're not equal to one another, we're getting an output of 1. Do you understand this?
Could you just say that one more time, please?
Yeah, sure. So basically, remember how in the NOT gate we had a logic made that whatever input we get, we're going to invert it to get the output. So if we have an input of 0, it becomes 1, and if we have an input of 1, it becomes 0. Now for Zoro Gate, the reason we have this expression and we made it into a gate is because that, like, whenever you get certain inputs, we have two inputs, right? A and B. Now if those inputs are equal to one another, then the output is going to be 0 or it's false. But if the inputs are not equal to one another, so for example, if A is 0 and B is 1, or vice versa, then the output is going to be equal to 1 or true.
All right.
Okay, and you'll see that this table and this table that we made with the outputs 0, 1, 1, 0, that was the output we got, right? Now notice in this one, we're going to do the same thing with this logic, and we're going to get the same answer because 0, 0, when A is equals to 0 and B is equals to 0, then we're going to get 0. If A is 0 and B is 1, that means they're not equal to one another, so we're going to get the output 1. Here, again, they're not equal to one another, so we're going to get the output 1. And 1 is equals to 1, so we're going to get 0. And notice how this output and this output is the same.
All right.
Okay, do you get it?
Yeah, I get it now.
Okay, great. So that was like basically the explanation of how the Zor Gate works. Now let's go over to some questions. I want you to try solving this. Okay. They're just basically asking you to match the names of the gates to the symbols. So what's the first one?
The first one.
Yeah,
Um, Wait, Nand, I think. Yeah, it's Nand.
yeah, it's not. Let me
Zor.
actually take a picture of this and put this inside the Word file so we can draw it on that easily. Okay,
Nand.
so the first one is Nand.
Zor.
Yep,
And
yep.
Nor. Not.
And you get 4 marks just like that. Okay, now let's try another one. Okay, so complete the truth table for the NOR gate.
For the Nor gate.
Yeah.
Nor is um it is 0. Oh no, wait. Wait. Aren't we supposed to have like another column?
See, that column was for you. You can make one here and you could just do it for your own like working, but that column is to help you out with the answer. But in like the shortcut way to do this is that you know that NOR is a combination of what two gates?
A and B.
No. What does NOR mean? Like what is the two gates that
Or
we
or
use?
or.
Or and not, right?
Yeah.
Yeah, so now we know that whatever output we get for OR, the opposite of that is going to become the NOR gate output. So what, just like out of out of the top of your head, what does the OR gates output give you in this with these inputs?
Um. This is going to be 1.
No, that's a NOR gate. I'm talking about the OR gate. Like just normally, what does the OR gate output give you?
Oh, the OR gate
Yeah,
is 0.
0, 1, 1, 1, right?
Yes.
So invert that whole output, and you're gonna get 1, 0, 0, 0.
Yeah, that's what I was doing with Nor.
Yeah, exactly. That's exactly what you need to do. So you don't always need another column in or anything, but you could use that as well. You can make it separately if you like.
Okay.
Okay. Write a logical statement that corresponds with the following logic circuit. I'm gonna make this on the Word file so that you can get there. Okay. So for this the logical circuit that we have, could you try making a logical statement or a logical Boolean expression like we did
You mean
last class?
truth table?
Sorry?
Oh, you mean like writing the X equal thingy?
Yeah, exactly.
Um. Okay.
I'm gonna do it like as you do it as well, so that you can keep checking your answers, and wherever you don't understand, make sure you ask, okay?
Okay. Wait.
Okay. Are you done?
Wait. I don't get this. N- Not gate.
The not gate. Okay. What expression did you get?
I got a dot b and then dot, and then I was trying to do not gate, but I kind of got stuck.
Okay, so remember how we discussed last time that you whenever you look at a logic circuit, you look from the left to the right. Now I went from the left to the right and started from the top, right? So A dot B, you already got that, which was this part of the equation. Now notice how this lower part at the left, the wire is breaking, like it's splitting into two from B input, right? So when this goes with one input to a NOT gate, whatever input you're getting, you're basically inverting it, right? So B is just being inverted over here, like this NOT gate. So if you feed, this is what's happening, right, in the NOT gate. You feed this B into the NOT gate, the output you get is going to be B bar,
All right.
okay? And this output, this B bar output, is going into an OR gate. So I'm going to make the OR gate here. This output is going into the OR gate as like one input, and the second input here is going back to C. So I'm going to write C here and put this here. So that means whatever output you got from the NOT gate, it's going into the OR gate as an input, and then C is in the other input. So it's going to become B bar plus C.
Um. So that's the not gate, right?
The triangle, yeah,
Okay. And this is the OR gate, which outputs the
B bar
input
plus
of
C.
triangle.
Yeah.
All right.
Okay. Um. All right, and then I just write this part here, this part. So B bar plus C. And then these two outputs are going into this, the AND gate. So these two expressions are being connected by the AND gate, which is why I made like a dot here. And I put these into brackets as well.
So whenever they're getting connected, you always put a dot.
No, no, no. It depends on the gate. If this was an OR gate, this could have been an OR gate as well. Then I would have put a plus sign.
Um. Okay.
We'll do some more questions and then I guess you'll get the hang of it then. But then, do you understand how we got these expressions?
Yes.
Okay. All right. So this was the final answer that we get. Also notice how I wrote small letters and the small alphabet here and then big alphabet here. Don't do that in your answer. Make sure that you use exactly the inputs that they gave you. So if they're using capital A, you also use capital A and so forth.
Okay. So like if there are two same, like if there are two times like B bars, so you just write it once, right?
If there are two B bars, yeah, I didn't exactly understand your question.
Like there's B bar plus C and there's B bar plus C, but you only wrote it one time.
There's B bar plus C two times. Where?
Like in the
This?
gates.
One second. Let me erase this real quick so it's all right. Could you point it out by the by how close it is to the inputs.
Look, like found out two expressions that were the same.
Oh yeah, I just wrote it twice to explain it, the answer.
Oh, so like, but in the answer you wrote it only one time, right? And that's correct.
Yeah, yeah.
So we can do that in the exam or papers.
Yeah, you don't have to write twice. I just wrote it twice to explain it, like in the second time.
Okay.
Okay. Let's go on to the next question. For this logic statement, draw the logic circuit. So they gave you a logical statement here. Let's solve this one together. Um, they gave you this, and we're going to make a. Make this bigger so there's more space. Okay, so they gave you a logical statement, this logical statement here. And now we're gonna write this in a Boolean expression. Right now, this is just a statement, right? With like, there's English in it, and they're telling you the values of everything. Now we're gonna convert this to the expressions that we were using before, like these a dot b bar plus c and such. So let's convert this first. X is equals to 1. We know that x is equals to 1 means true, right?
Yeah.
So we're just gonna write x is equals to. So there's no bar on top of it, there's nothing. And so x is equals to 1 if in a double bracket they said a is 1 and b is 1. All of this basically means a dot b in a bracket. This part.
All right.
Do you understand this?
Yeah.
Okay, so this part is in another bracket, and we've written this in the certain bracket that they defined to us beforehand. Now, then they said or means plus, right?
Or means yes.
Yeah, and so the next bracket we have is B is 1 and C is not 1. So they told us B is 1, so we know that we could just write B first. Then they had an AND gate here. So AND gate is the dot, right?
Yeah.
And C is not 1. That means they're using the NOT gate. Sometimes they won't write not 1. Sometimes they could write C is 0, or they could write C is not 1 like they did here. And both of this just basically means that C bar.
Okay.
Okay? So C bar and close bracket. Do you understand how we converted this?
Mm, Is yes, I do get it now.
Okay.
But like in the normal expressions, like the common ones, you only wrote A and B. But in this one, there's also C, right?
Yes, they're using three inputs. They're using three letters. That means they're using three inputs here.
Oh, okay.
Okay. And I'm just going to point this out. This part is this part was this, and this was this. Okay, now let's try
Yeah.
making the logical diagram for this. Do you have an idea how to start that?
You do have to connect the lines for A and B.
We're going to connect them using the gate. So we're just going to solve the brackets first, always, and from the left to the right. So what's the first bracket that we have?
A multi A dot B. Oh
Yeah,
wait,
so
I know. I know. Um, uh, is going to be wait. And gate.
the AND gate, yep. And we're going to give it what inputs?
Um, for and gate inputs are two, right?
Yeah, there are two. And like what letters are they using to connect with the AND gate?
A and B.
Yeah, so we're just gonna write A's input line and B's input line. Second. The A input line going straight and the B input line going straight goes to the A. And then we're gonna connect this with the AND gate.
And yes, the one with the dot.
The one without the dot because, oh, acha, you mean the, okay, yeah. And so we're just gonna get this like just an empty line here. We don't know what comes after just yet. Or actually, let's do this part first.
Wait,
We've
okay.
got the first bracket done. Sorry?
Nand Gate is with the dot.
The NAND gate is with the dot. We're not using NAND though, right?
Oh yeah. Sorry.
It would have been NAND if they said A is not one and B is not one, then that would have mean that they're using the NAND gate.
Yeah. Sorry.
Okay, since it's A is one and B is one, we're just doing A dot B. Yeah. So this output is going into what? What like after this bracket, what do we have next? The plus sign, right?
Yeah.
So we're gonna make. I'm just gonna use a different color so it's easy to point out. We're gonna make the OR gate here. And now we don't know what comes here, and we don't need to look at that just yet because we're gonna do the next bracket that comes next, this part. Let me
It is.
actually, sorry?
Um. Uh. It could be. Wait. An OR gate, I think.
What could be an OR gate?
No. Wait.
This is an OR gate, right?
Yeah.
Okay, we've already made the OR gate that connects everything since there was only one plus sign. But we're done with basically this part of the question. We're done with this. We have to get to this part.
Yeah. This part doesn't seem like right. I don't know.
Okay, how like this part is this part of the statement, right?
Yes.
So what do you think the statement should be in Boolean expression?
B is one and C is not one. Um. I somehow Zor looks like it, but Zor has two brackets.
Yeah, Zor has two brackets, but this is just like at its own statement. It's not meaning some gate or anything. We're gonna make this gate ourselves.
Yeah, I know.
So it's a like it's not Zor at all. It's just another B dot C bar because right now here they said B is one, meaning we're just gonna write B as it is, and the dot gate, the dot and the AND gate, and C is not one, meaning it's C bar.
Yeah. Okay.
So yeah, so right now what we're gonna do is that we're gonna break this wire, B bar, the B input wire, so that we can use it in this bracket. Let me take this down here. And it's going into the AND gate, right? Because it's connected with a dot,
Okay.
right? So we're gonna make the AND gate, but we know that the AND gate has two inputs. What's the second input? C bar. We don't have C bar yet, we have C. So we're gonna make C bar by putting a NOT gate, and the output of that is gonna go into the AND gate. Do you understand this?
Oh my God. It's kind of confusing.
Okay, we're gonna just solve it again one more time. But basically, this what I made here, let me use this. this part that I made here is equal to b dot c bar. Because what I made here was b, right? B went into the AND gate, so I have b here. And this is the AND gate, so I'm going to write dot here. And what else am I putting in it? C is going into a NOT gate, which means I'm getting C bar here. And C bar is going into the AND gate. So I'm going to write C bar here. This means this is what, the output of this gives me.
All right.
Okay? And so this line, I'm just going to erase a bunch of this so we can move to the next part. So the output of this is what? It was connected to what? The OR gate, right?
Yeah, I was connected to the OR gate.
So this
It's
output,
supposed
I'm
to be
just going to
connected
lead
to the
it to
OR gate.
this. Yeah.
Yeah.
And then the output of this is actually X.
All right.
Okay? Do you understand this? Do you want me to do this one more time?
Wait. Let me look at it for some time.
Okay.
All right.
Do you get it now?
Hello. Um, yes.
Okay. Are you sure you don't want me to repeat this answer one more time?
Could you repeat the NOR one? The not one, sorry. The not
Yeah,
part.
yeah, sure.
The not
Yeah.
gate.
Okay. So